Hi everybody, my name is Tom Moore and I am a developer advocate at AWS. Welcome to my session, Recognizing Photos with Custom .NET 6 Applications. In this session, we're going to talk about the Amazon Rekognition service and how you can leverage that service in your own custom .NET applications to bring computer vision into your apps. This is the agenda for the session. We're going to start off with an overview of what Rekognition is and the feature set that's available today for you as a developer to use in your custom apps. We're going to dive into a couple of use cases that I've used to build a sample application and a little bit of a discussion about why those features might be important to you. After that, we're going to jump into the code and see the features in use, and then we'll wrap it all up with where you can get access to the code so you don't have to transcribe my code from the slides and use it as a basis of your application. So first, let's answer the question, what is Amazon Rekognition? To start off with, Amazon Rekognition is an artificial intelligence machine learning service. It's a specific type of machine learning called computer vision. Now let's think about artificial intelligence for a bit. When I was a kid, artificial intelligence was something out of science fiction movies where the robots would come around and try to eliminate humanity. A little bit later, as I was a teenager, artificial intelligence was limited to really chess applications and games that were in use. Even 20 to 30 years ago, artificial intelligence was something that you had a whole lot of really specialized people that worked hard at trying to figure out how data correlated. These days, artificial intelligence and machine learning are baked into services that you can call from your own applications quickly and easily. Rekognition allows you to bring that computer vision to analyze photos and videos too. Everything that we're going to talk about today is accessible directly through APIs. And if you're a .NET developer, you can use NuGet to add this functionality into your applications. The feature sets that are available today. First up, let's talk about content moderation. And really what we're talking about with content moderation is, does this photo or this video contain anything that is potentially offensive? So nudity, violence, drug use, etc. We're going to dive into this one a bit more in a few minutes because it is part of the sample application that I'm going to show as part of this session. Next, let's talk about face detection. So face detection is looking at a photo and determining whether or not there is a person's face in that photo. From there, we can extend into facial analysis. So looking at that face and determining is the face male or female, young or old, are they happy, are they sad, etc. An additional set of functionality around this is the facial comparison feature. So if you think about some services that are available online these days, you can upload a photo into the service, say Amazon Photos, for example. When you upload your photo, you can find out that a person's face is visible. You can also then look and find out that that person matches other photos in your library as well, and automatically start building out albums of a particular person. The next use case is labeling. Now this is another one that we dive into a little bit more in the sample application. But basically, labeling is looking at a photo or having the computer look at a photo and figure out what is in that photo. So is there a table? Is there a tree? Is there a person? What else is in the photo? Again, this is a use case we dive into in a sample application, so I'm not going to go too deep into it right now, but it is available and you'll see how to use it. An extension of labeling is the ability to detect custom labels. This is very useful for if you have, say, a business logo and you want to be able to search through photos to find where your logo is being displayed. Custom labeling will allow you to detect the presence of your logo in the photos. Text detection is another capability that's available through Rekognition, and this is really looking at a photo and figuring out, is there text on a sign or somebody's shirt, something of that nature. And it goes beyond the simple identifying the text and uses machine learning to plug in some of the gaps. So if you consider if somebody is not quite facing square against the photo as it's taken, there might be some distortion, and a simple OCR process may not be able to pull that text out, whereas a machine learning based process can. And finally, Rekognition also enables celebrity recognition. So is there a famous person in your photo? Being able to pick out their face and identify those photos with that capability. So let's dive into the idea of content moderation. Now, why would you want to do this? Well, in my case, my sample application is a media catalog for photos. It allows people to upload their photos to the site. It then indexes them by what's in the picture. So we can then go back and look and say, I want to find all photos with, say, an animal in them. However, I don't want people to upload photos to my sample application that are offensive, because that would not be a good thing. So I want to implement some automated moderation for the photos that people upload. Now, your use case may be a little bit different. Maybe you allow users to upload photos to become part of an avatar on your site, something of that nature. You still may want to catch photos that are not appropriate for your web page. So here's a flowchart of the basic use case. My users upload a photo. I then save the photo to Amazon S3. Once the photo has been saved, I'm going to call Amazon Rekognition and request photo moderation. Once we get the results back, we can make a decision about whether or not we want to allow the photo. Now, Rekognition is going to do two things. The moderation labels, so anything that it potentially finds that may be offensive, and a confidence score. From there, the person who is writing the code has the ability to make their decision based on what they want to allow or not. For example, you may want to block all images that are potentially offensive, which is what my application does. Or you may want to become a little bit more selective about what you allow and what you don't allow. We're going to have a look at the set of items that can be moderated in just a moment. Now, these are the categories of things that Amazon Rekognition will flag as potentially offensive. Every item has both a top-level category and a second-level category. The second-level category gets a little bit more granular. As we'll see when we jump into the code sample, you have the ability to interpret these results any way you need to. For example, in your application, you may want to block all images flagged with explicit nudity. You may want to block some, but not all photos under the suggestive category, perhaps, and maybe you don't care about tobacco, so you'll allow that category to go through. The other thing to understand is that each of these labels has a confidence score. It's not a yes or a no. So you may want to take that into consideration. So for example, if an item is flagged, it will tell you the level of confidence that Amazon Rekognition has that the image contains what has been flagged. The higher the confidence score, obviously, the more likely it is to be in the image. Now for my application, I'm simply discarding any photos that come back with any labels. But you can get a lot more granular than I do. So this is how it works in practice. The user of the site uploads a picture. In this case, it's a picture of a handgun. The computer vision scans the object and automatically compares this against a machine learning model that is trained by AWS. So there's no work for you to do to train the model, it just works. The machine learning model then identifies the data in the image and classifies it for you. In this case, it flags the weapon, it flags the image in the violence category with the weapons subcategory, and then returns that data to you, back to the caller. Now you can Keep in mind that you can have multiple labels flagged in the same image. It's up to you to make sense of what's been flagged. This is the request. This is what the request looks like. And as you can see, it's pretty simple. You configure the request object, tell it where the object is, and what the minimum level of confidence that you require is. As with everything AI related, it's not a yes/no, it's how likely is it. You can make matching more strict and thus reduce the number of items that are flagged by updating this value. The higher the value, the more exacting the match is going to be. If you don't supply a minimum confidence level, the value that is assumed is 55%, so slightly more likely than less likely. You then tell Rekognition where to find the file here. In this case, I'm using an S3 location for the file because I upload the file and save it to S3 as the first part of my process, which is probably the easiest option to use in my use case. However, you can also pass the actual photo data instead of a location and have Rekognition use that data instead. And this is all it takes to get your response back. As you can see from this sample code, I'm taking a very conservative approach to moderation. If something gets flagged for any reason whatsoever, I'm just discarding it. However, as we've discussed, you have the option to make some decisions in the code based on what is returned. You might want to save the image and flag it for human review, for example, rather than simply deleting it. You can cycle through the return values and make a decision based on the data that was returned. For example, you might want to consider the confidence value that has been returned, what the categories are, and what the subcategories are. The second use case that I've implemented in my sample application is the idea of label detection. So what is label detection? Simply put, label detection is having the computer look at the image and determine what is in the image for you. The interesting thing is that because the computer is doing the looking, the analysis doesn't filter out some of the things that a human would, based on some cognitive biases that may be going on, and the discarding of items that we don't consider important. Let's consider this first use case. We have here an image that you may recognize. It's provided from the Smithsonian Archives. So what do you see? Well, you see George Washington, right? Maybe you thought person, maybe you thought painting. But what does the computer see? The computer picked up something that your brain may have filtered out. For example, shoes, furniture, there's a table, there's a chair, and also the fact that this is art. Now keep in mind that computer vision is not infallible. Sometimes it gets things wrong, and sometimes in some fairly entertaining ways. Like somehow thinking this is a horse, which still boggles my mind. That said, I didn't filter out any of the results based on weighting, so it may have had a low confidence score for the idea that this is a picture of a horse. Just goes to show that computer vision is good, but sometimes you do need to have some human backup to interpret the results. This is the code to scan your photo with the label detection. As you can see, it is similar in nature to the code for moderation. Now in this case, you're wondering, I did not set the minimum confidence score before I processed the previous image that thought the orangutan was a horse. You can set this value here, as I indicated. You can also specify the maximum number of labels that you want returned. And again, you pass the location for the image that you're trying to scan. Once again, it can be either an S3 object, or you can pass in the actual data that it makes up the image and get it back. And yes, processing the return results really is this simple. You simply get the list of labels back from Amazon Rekognition, and you can iterate through them. You can then look at the confidence score and the labels to figure out what you want to do with them. So now let's dive into a live demo and see the application and specifically the code to interact with Amazon Rekognition in a live application. Now, the first thing we want to look at is the moderation code that is in place for my first use case. Now you can see here I'm in Visual Studio. I have opened my media library sample project over in the Solution Explorer. And over here you can see the AWS Explorer that's part of the Visual Studio Toolkit. And we'll look at that in a little bit because that's going to help me browse my Amazon S3 bucket for the images that I upload. So let's run up the application. Take a few minutes here. Okay, so my application is started up, and you can see it's pretty much a standard ASP.NET MVC application for .NET 6. So what I'm going to do here is I'm going to hit the upload button, and we'll have a look at the code as it goes. So I'm going to browse, and I have a couple images that I'm going to use for samples. Now the first one I want to do is I want an image that's going to be flagged with moderation labels, just to show how that works. So I'm going to select that and upload it. As you can see by the thumbnail, it's an image of an explosion. And I'm going to click the upload. Now, up until this point, what's happened is I've run the code to save the file to S3, and we can actually see here, if I look at my S3 bucket from my media catalog, the image has already been uploaded, and we can see what the name is. So the name of the file is the object key in S3. Now the way I've done this, I've given it a GUID for the name, mainly so that as I'm testing, if I upload the same photo over and over and over again, it gets a new name, which just makes it easier for me for testing. So now what I'm going to do is, you can see here I've created the Rekognizing client, which is a standard practice for for interaction with all of AWS services. We create the client and then we interact with it. So I'm going to call the detect moderation labels async call and await the results. And to that I'm passing in a detect moderation label request object. Now as part of that, as we saw in the slides, I can pass in a minimum confidence score. In this case, I'm saying 75%, and the location for the object. So you can see here, I've got an image parameter, and the items I'm feeding into that image parameter, I'm saying it's an S3 object, and with a bucket name, that's the name of the bucket that's created in my account, and the object, which is the name of the image that I uploaded, which corresponds to the object key in S3. Okay, so the result of that is this results item. So let's just have a quick look at the results. Go here to go quick watch. You can see that the results object that is returned has some data in there, and one of the things is this collection of moderation labels. So I've got two labels that have been returned. Now if you remember from the display, there is a top level category and a secondary level category. So here you can see I've got a top level category of visually disturbing, and I've got a confidence level of a little over 99%. The other item in the list indicates the parent name is visually disturbing, which is the top level category and indicates the secondary category, explosion and blasts, again with a confidence score there. So I can step into this and I can look at the results. Now in my case, what I'm doing for my use case is anything that gets any content moderation labels passed to it, I'm disallowing. So I'm going to say here, image allowed equals false. And then what I'm going to do is I'm going to collect all of these flags or all of these moderation labels and put them on a form so the user can see why their image was rejected. And you can see here the return result. So I've got a simple rejection page that I've created, and what I'm telling the user here is the upload was rejected, and these are the reasons why. Explosions and blasts, visually disturbing. So that gives you the ability to provide the feedback to your end users. Now let's look at a photo that would be acceptable. So I'm going to click upload once again and browse. And in this case, we're going to go back to the picture of George Washington once again. And I'm going to hit upload. So as you can see, I'm going to do the same request for validation. However, when I step through the code this time, I've got no moderation flags, so my image is going to be allowed. And I will step through. Okay, and now you can see in my media files, I've got the picture here. This is the original name. I've saved that in my metadata so that I can correlate things back. And we're ready for the next use case. Now the next use case that we're going to dive into is the idea of using the label detection functionality for Amazon Rekognition for one of these photos that I have uploaded. In this case, the photo of George Washington. So my application, I go here to the process section and I click list. Now here I can see the file that I uploaded, and I'm going to click the button here that says process. Okay. So we're stepping into the action handler here, and there's a couple things that I've added. So this function has a recording from the AWS X-Ray service, which can help you gain some metrics along the way as to how your application is functioning. And we'll dive into that a little bit in the video towards the end. Okay, next thing I'm going to do is I'm going to create a view model that I'm going to use to pass data to my form once it's been completed. So this simply collects some of the data for the items for the image that's being processed. Once again, I'm going to create the Amazon Rekognition client. And I'm going to create the detect labels request. This is very similar in nature to the idea of the moderation request. However, this is focused around detection of labels of items that are inside the image. So once again, I can pass in a minimum confidence level. Again, I'm using 75. If you don't pass anything in here, the confidence score will be 55. And max number of labels. So I can set an upper limit on the amount of labels I want Rekognition to send back to me. Okay. And here, once again, I can call the Rekognition service. Now all I'm going to do in this case, I'm simply going to cycle through all the labels and send them to the form so we can have a look and see what they are. Okay. Now, passing in a a confidence score of 75% has limited the results that are coming back. So I can see that this is in fact art, a painting, there's a person, and there is a human. So I can hit save and I can keep my results. Now what would happen if I lowered that confidence score? So let's stop the execution here for a moment. And I want to go back and I'm going to comment this out. As I mentioned, the default score, if you don't provide one, is going to be 55%. So I'm going to run up my application once again. And I'm going to go back to the process, click on my list link. And once again, I can process that same image. Now, again, I've lowered the required confidence, and so you can see that more items are coming through here. So in addition to art, painting, person, human, we also have a shoe, which was detected here. We have clothing, because George Washington is wearing some clothing. There is footwear, again the shoes, apparel, and furniture here in the background of the image. So I can, in my application, what I'm doing is I'm selecting all these items that I want to keep and associate with the image. If I didn't want to have some, for example, maybe I want to remove furniture, I cannot, and let's say apparel, I can remove those from the list, and my application won't save them attached to the image. So I'm going to click Save here. Now you can see my application has changed the list item. Instead of saying View, instead of saying Process, it now says View. And what I'm doing is I'm actually retrieving the values that I saved attached to that image. So, in this case, we're not getting the additional items that were on that list. Okay, so that's the operation of the sample library or the sample application. A couple things you might be curious how all of this works. Over here in the dependencies and packages, you can see we have the AWS SDK, and I've got a bunch of subcomponents built in that I'm accessing. I'm using DynamoDB to store my data. I'm using the extensions .NET Core. It's helping me set up logging that's going to CloudWatch logs. And Rekognition, so this is the critical one for gaining access to the Rekognition items, such as the Rekognition model for detecting labels. And X-ray, as you can see here, I'm using X-ray in this application to record the data for segments. Now I mentioned before, as we were stepping through the code, I mentioned Amazon X-ray and that we were tracking some of the interactions with X-ray. X-ray gives you the ability to see what's going on in your applications. So let's have a look here. Once we get into X-ray, we can go here to Traces, Traces will be the data that's been instrumented. Okay, and we can see the URLs that have been accessed. And we can see some of the traces that are being used. We can see for a particular call, say the DynamoDB, the media catalog, one of these calls, we're going from the media catalog application, and that's taking just short of 16 seconds. And you can see here that from 6 to 12 seconds, so 6 seconds of that was in DynamoDB. So this helps you to understand where your application is taking the most time and where you may need to improve to improve upon it. Obviously, if you're going to implement Rekognition in your own application, you're going to want to know how much it's going to cost. There's a link here for the pricing options that are available. So AWS to Amazon.com/Rekognition/pricing. The pricing is based on per image that you scan. So just be aware, if you scan an image multiple times for through multiple API calls, you are going to get charged for each time you do the scanning. So where can you get the code? The code is available on GitHub. And here is the address. So it's in the collection of AWS.NET guides within the AWS samples organization. And you can find this code at Sample Applications 2022/Media Catalog. And that's it for my session on using Rekognition with your photos. Thank you very much. Again, my name is Tom Moore. If you have any questions that you want to ask me about the application or to get in touch, the address is moretom@amazon.com, or you can find me at Twitter at basementprogrammer. Thank you very much.